everyone. Today I've got a video that is not exactly related to the thing that I was originally working on, but it contains quite a good amount of progress. So, as you may be already noticing, the first thing that is going to be very obvious in here is that now Lightning looks really good compared to what it was like before. It's actually really nice right now. I have to overhaul the way that the rotation worked for Lightning, and that was because I was checking out the remaining files from the FBX map for the versus boat map, and I had realized that the output values in the XMB file when decompiled were not the way that I thought they would work. So initially, this is something that I had done at the very beginning, and I had completely forgotten about that. I had assumed that Lightning was, since it was reading as a vector 3, I assumed that it was like completely just a rotation, and with some of the values that I had seen, it looked like degrees to me. So I assumed it was degrees, but it was wrong. And later I looked at some other maps and I was like, this looks like radians, I guess, kind of weird values. So I tried that out as well, and it didn't work either. And then I realized that all of the vectors used for the direction were actually unitary vectors, and unlike the particles where it says vector 1 and vector 2, the code actually refers to them as direction. And it quickly clicked on my head, and I realized that they are just the same as the particle effects. They actually use the exact same system where we start with a unitary vector and we rotate it, right? So basically, when you realize this, you notice that under the hood the system actually uses directional vectors for everything, right? Like a director vector that you would use to define a line trace or some plane or whatever, right? So yeah, the Lightning is basically fixed now. All of what we've seen up until now was actually wrong, and I checked this other thing over here, which is very important to see, which is the original map that I talked about, that we have the remaining FBX file. And if we select different meshes, there's not really any curious properties to see, but the lights, they do have something interesting. They are not exactly lights, they are dummies, they are empties, right? Like the equivalent of an empty in Blender. They have the following: they have the panel with custom attributes. Yep. And these have been preserved in this FBX file. Even without having the original plugin that they may have made for exporting in 3ds Max. So this makes it further clear that they probably used at Arrowhead a custom piece of code for 3ds Max that would export this data, right? Or any similar Autodesk program, because the format used for the FBX is actually, proprietary for Autodesk. So the version of this FBX, as far as I know, is only possible to open using 3ds Max. Like Blender doesn't even open it because it doesn't recognize this format. It's not capable. They haven't reverse engineered that yet, right? Maybe a simp does open it nowadays, that library, but I think that Blender uses their own implementation, so that's another story. But anyways, the point is that this panel contains a lot of information that may look very similar to the information that I actually made in my panel. So I literally reverse engineered this before finding out that this information was preserved within the original FBX files, the 2 or 3 that are left within the game files. So that's really good, actually. I am really glad that this information is here because it gives us a bunch of hints. So first of all, it only has types for directional and point, and I actually looked at the code, and there's also a spotlight type, which is probably not used for whatever reason. So this either says that this is an older version of the plugin and this is an older version of the map and not the one that is in retail, right? Or the final version, right? Or that maybe no spotlights are ever used in Magicka for whatever support reason, right? So maybe they just don't use them, or maybe they had the idea to support them, but they never supported them at the end. So we'll have to test that out in the future to see if it works or not. Second thing, we see the shadow map size, which I set as default to 64 in case it was going to be too big, but we can see that the official maps is 1024, so 1024. I put it on my Blender plugin for my light settings. I set the shadow map size to 1024, right? And pretty much it looks really nice now. And if we go back here, we can see that it's got more settings like the variation type. It's got pulse, flicker, candle, strobe. For me, rather than pulse, is sine, because that's what it's called within the code. It's sine, but it's the exact same thing. It's a pulse, right? I could add that to the description actually. But anyway, we got the variation speed, amount, the reach. Well, that's just the name that I gave it because it was like a more generic way to refer to the radius, because it's not exactly a radius when we talk about a directional light. But we can see here that if we go somewhere, we go light radius. So yeah, they don't really care about that naming convention. They just named it light radius. I named it reach because technically for a directional light it's not a radius. It's I mean, for a directional light there's no radius at all. I don't know why this one is set to 5.0. They maybe copied the other lights, I guess, or something. I don't know. You look at that. This light right here has a point, spot, and directional within the data. That's pretty weird, huh? And 256 for a map size. Anyway, another interesting thing is the fact that what I have is a diffuse color and ambient color, which in the case of Blender it can be nicely seen as a color selector, you know, color picker. So we have the same properties, but they have, apart from specular intensity, which I think I named specular amount, variation speed, blah blah blah, and use attenuation, they also have something named diffuse intensity and ambient intensity. Now, I don't know how these values are used. Maybe they multiply these values right here, or maybe they are completely ignored. I don't know. I just say this because there is no diffuse intensity property when you decompile the code. So I don't know where this information is stored, but I'm betting that it is some sort of multiplier, and it just multiplies these values right here, right? Like, it's probably just that. And we can actually check it, because I didn't check yet, but we can go over to the boat JSON file that I think I still have open around here. Yes, I do. So if we look over to the diffuse color, indeed it is over 1.0. So the values clearly range from 0.1 for a RGB value, but the multiplier gives us a range outside of the 0 to 1, which means that it's making them, you know, when you oversaturate a color by making it too intense in any graphics program, by going over the limit and it starts to look like nuclear white, that's probably what they are doing. And this might be related to some sort of bloom property or some sort of emissive glow or whatever, you know. It doesn't matter. The cool thing about this is that we now know more things about how the engine works, and we have implemented Lightning properly, right? And we also know that the map size that they use is usually 256 for point lights and 1024 for directional lights. I don't know how much for spotlights, but like, the point is that we have a proper reference for this data. We could have looked at that from the exported JSON file, but the whole semantics of what this value being over 1 really meant is kind of lost. We could have assumed there is a multiplier value, or we could have assumed that maybe the system goes from 0 to 2 if we never found any value over 2.0, or we could have assumed it's actually value from 0 to 255 and it's just that it is always very dark or something. The whole semantics of the intensity is completely lost, right? And it is so good to finally have them back, because we can check out all of the properties here and start mapping them out and improve the lighting system even more, right? And this would mean that we could technically go ahead and, if we go into Blender over here, right, and just make a few changes in the code, we could end up having a system to add lighting of different intensities to, for example, next to the particles, right? So yeah, that's really good, to be honest. That's really nice. really nice, because right now if we go ahead and place a point light, right, we can place a point light in here, and rather than having to go to some sort of setting in here, we can just go ahead and go to the light, and we know that this is a point light, and we can change it to point, sunspot with the default Blender stuff. Because I wanted to reuse that option, right? We could technically just make everything point lights. The reason why I'm reusing this is because you can technically just render out your scene. So if you want to make a cool image for your scene, you could render it from Blender. So it would be great if we could reuse those properties without having to go insane, you know, remaking everything. So let's just go ahead and put some lights in here. We can actually better see these like that, probably. Yep. And we're going to make a cool candle, probably, or something. And we can check out the way that they made it and get some proper values and actually understand what it means. So if we look at the lights for the candles that they have, they actually selected variation type poles. Okay, so sorry, my recorder crashed, so let me just put this on my other screen to be able to see the values properly. So we can go ahead and start transmitting this information right here. So we know that for some reason they decided to use pulse variation type rather than candle for the candles, so we'll go with that sign. Okay, and what values did they use for the variation? They use variation speed 1.0. okay, variation amount 1.0, and sharpness is 2. The cutoff angle is 15. I don't know why, but we'll see what it does, right? We can use attenuation, and we got it, right? The radius for the light is 2 in this case, so we can pick 2 as well. 2 is already quite big in Magicka units, I think, right? So yeah, we got all of this stuff. We got the variation type, we got the variation speed, we got the variation amounts, right? We got the light radius, okay? We also got the cutoff angle and sharpness. So I would probably switch these two options around the order in which they are rendered, because it makes more sense, like how they have it ordered. And probably I would put the radius first, because this variation stuff could go at the end, but like, we'll keep it like that for now until anyone thinks this is a piece of shit design and needs to be changed, because the color will be the first thing to put for light settings, in my opinion, actually. And we've got the whole cast shadows at the end. They have it at the beginning, but I think at the end makes more sense, like Blender has it. You know, it's more or less down here. We have the shadow map stuff. Okay. Diffuse color RGB, diffuse intensity we're missing, diffuse ambient color RGB, we're missing the one. They also, by the way, put the ambient color to white, so we don't exactly know yet what that would look like, but we just need to experiment with that or find a map that changes that, right? Ambient intensity is 0.2 actually, and ambient, diffuse intensity 4.0. Okay, so we're missing those two things. We got a specular intensity rather than a specular amount, so we can rename that actually to be more consistent. And that's it. Those are all of the properties. So I'm gonna change the colors to something more or less orangish, I guess, and that's more or less what they have. And I'm going to go ahead and modify the code to add the whole intensity values and reorganize the panel a little bit to see what it looks like now. Alright, so here we're back again. I actually had to leave the computer for a while, so let me remember, where was I? Okay, right, so we were with the whole light business, right? The modified menu panel here. And we can see that I've added a bunch of default values to this thing, right? And we're actually going to visualize what the effect will be for, you know, the directional light to actually be, you know, having a specular intensity rather than of 0.0 of 0.5, and rather than having ambient intensity 1.0, we're gonna have 1.2. 0.2, right? So We're also going to add a bunch of lights, and we're going to see the different effect of each of them. And I'm going to have one with an diffuse intensity of 1.8, for example, right? Or 2.0 actually, and let's just see what happens, right? And I'll export the file and put it into Magic. By the way, another thing that I wanted to mention is that I have modified the exporter for certain reasons. And to make it easier to debug, I've renamed the variables internally and stuff. And also I've added an export animation data boolean, right? So that we can just configure this to either allow the animation data to be exported or completely ignored, because right now it's not fully implemented. So to prevent crashing with partially generated data, or to also make it easier for people who want to debug their map without animation data and make the export times faster. So yeah, that's all I really wanted to mention about that. It doesn't have anything to do with lights, but it's another change that I've gone through. Okay, and here we are in Magicka. This was what the map looked like before reloading it. Okay, so I'm gonna make a single pass before we look at the changes. I did not reload the map yet, and now if we quit and start up again, it should load up the new version of the map with the changes that I've made. It's taking a while to reload the file. And well, as we can see, the ambient lighting is basically the lightning present in the shadows, so it's way darker now that we've removed the ambient lighting. And also, now that we've added point lights in here, it should have a little bit of brightness, but since the ambient light is too low, it doesn't really appear to be very obvious how much it's lighting up the area. So yeah, that's kind of unfortunate, sadly. Alright, so let's go on. Here we are. So I restored the ambient lighting for the skylight, so basically the entire environment is bright as day again, because that's what the map looks best in my opinion. It was meant to be a daylight map. And the lights, well, this one and this one are the two only lights that have their variation in their light. The other ones don't have, and there's no lights in the other particles. So as you can see, well, if I put the ambient light too high, I had a problem a while ago where they would just glow too much. As I explained before, it would go nuclear white. So now it makes sense why ambient lighting is set to 0.2 in the point lights in that map, right? And the multiplier for the diffuse lighting for this one is 1.0, so it doesn't get multiplied, increasing the value. It's just the original value. And this one right here has a multiplier of 2.0, I think I put to it, right? And as you can see, they even cast shadows with my character walking around. So I can make a bunch of really cool effects with the shadow coming from the skylight, and also when this glows back up again, we get another shadow casting in here of my character itself, right? So that's pretty nice. It looks really great, actually. And yeah, that's basically it. These lights right now are working with the pulse or sine wave variation, but we could change the lightning variation to actually make use of something like candle variation or whatever, right? And we can even change the variation speed, so we could even have disco lights actually. So if you make an animated level part with like purple, red, and whatever lights moving around, you could have something like disco lights going on. So that could be pretty cool of an experiment to make actually. I'm thinking that that's going to be one of the next things I might do when I actually fully implement the animated level parts. So yeah, that's all I had to showcase for this video regarding lightning. We could maybe showcase something else, putting a bunch of lights of different colors and have like a demonstration of color mixing as well. Yeah, that could be an interesting thing. Okay, so I've made a few changes to the lightning. I've made the map extremely dark. It looks like it's nighttime, kind of spooky or whatever, for the sake of better visualizing the lightning. The diffuse color for the skylight right now it's a purplish color, while the ambient color for the shadows is a bluish color, right? And if we go over here, whoops, I didn't see the barrels. We can see we got over here a red light, a green light, and here barely visible there is a blue light, actually. So, yeah, it's gonna take a while to get used to the way lighting works in Magicka. It's because there's like two values to have into account rather than only one, and the color mixing is very aggressive sometimes, but sometimes not so much. For instance, here it's not obvious that the center is kind of white looking, right? But before the lights were closer together and they looked pretty much like a very light green color, so almost whitish, right? So it's clear that whatever the case, the lightning has like a greater tendency towards green and lowered for blue, and we know that because we also explored the file format for XNA, and we know that some of the color types that they have internally give more bits to the green color, because technically the human eye can detect more tones of green. So it might require a little bit more getting used to tuning the blue colors, because they look, I mean, on my screen right now this doesn't really look blue. It looks like really pale bluish, but the background is also kind of green, so since the floor is green, it might also be more aggressive when it comes to green color, because as you can see the red kind of looks orange when mixed together. But yeah, the point being that we can do lightning right now, we get accurate shadows casting, and we can even add light variation to it, and it works just fine, you know. It works really nicely and it's pretty cool. And we can just go as far as probably even adding some point lights to this right here to check out how they would look. Yeah. And right now what I've made is make a little test, and I have created these two lights right here and they have a, well, blue light, but it looks kind of green because the ground is green, everything is green because it's grass. So this would look better if the environment was probably made out of a gray material like stone or whatever, right? But yeah, we do have working lights, and this one is a sign light again, and this one is set to be a candle, but so are these ones right here. And to be honest, I feel like candle doesn't really actually work in Magicka, which might explain why all candles are set to be sine waves. So we'll have to figure out what the proper way is to actually make light variation that looks good. Probably have two lights, like maybe one light that is always with a minimum intensity, and another that has some variation to, you know, simulate the effect of a candle, because a sine is obviously not exactly the sine wave. It's a pulsating type of light, so that's not exactly what a candle looks like, but it's better than nothing, you know. So yeah, this is pretty cool. There's pretty much not much else for me to explain regarding lighting, because it's all been said and done already. I guess I made this video too long for what it is, but yeah, pretty much working lights. Next up, hopefully working interactable objects and animation data and stuff.